All right, welcome to the stream. I'm going to get started in 2 seconds. First, I have to check my sound professionally by use of my phone, which is lagging just a hair behind me. I just want to make sure that my mic's up and going, that everything is working like it should before I pull this back. So there may be a little bit of overlay here. All right, welcome to the stream. Beautiful. My little cheap blue snowball, which I love this mic, is working fine. I'm going to keep this right up here. Now let's talk for a second. Let me tell you how observant human beings are, right? Like, I watch my stuff, I practice, I teach, I know my stuff. You miss stuff. I kept wondering why on my original countdown, it kept seeming like it was resetting, like it was 4:59 and it was 4:57, I couldn't figure it out. Because I set the time for a 4-hour countdown. I could not figure that out. I thought I was setting it for a 4-minute countdown. I kept wondering why it kept, like, to me it looked like it was restarting. Anyway, I just noticed it just now. Just saying. Okay. Let me talk about the stream for just a second and then we'll get started. Tonight I'm going to continue the discussion from class on discrete probability distributions, and I'm going to talk about a few problems, and I'm going to connect back to the calculator. A couple of changes to the stream tonight. I'm using my AnchorWorks camera. I know nobody's interested in this, but I like to at least talk about the hardware that I'm using. Using my AnchorWorks camera, which is more of a 4K camera than the old just 1080 Logitech that I had, which has actually worked great for years. Excuse me, I've had this AnchorWorks camera for a while. I never found a use for it, and now I've used it. I'm looking at my stream right here and here, and it actually looks to be a little clearer than what I had before. So anyway, not that anybody is here to look at me and say, oh, what a great picture. So I've got that going, and I've made some major breakthroughs. I think you hear me say every time, I stream from a 2015 iMac. Beautiful system, works fantastic. It's just 2015, it's 10 years old. So I have to watch what I'm running on here. And so I use Ecamm to stream with. And typically what I would do is from my iPad, I would transmit to the computer through Doceri, have Doceri on the iPad and up here. Doceri is quite the hog of a program on a Mac that doesn't have tons and tons of capacity to carry it. So I would have that going if I ever opened up Adobe to bring something else into the stream, because I wanted to look at a book or something. Sometimes with Restream I would do that. And it would just eat the resources up. And so, but now what I've done is I am screen mirroring using Mirroring 360, which I purchased the other day, which was not fantastically expensive. I guess when you add up all the little things that I get, it probably adds up, but I enjoy doing it. So just the Mirroring 360 is taking the place of Doceri. I still can run Doceri from the iPad alone, so it's not taking resources off of here and push it through. And so what you're seeing here with the discrete probability distribution in the background is a keynote presentation on my Mac that's coming through on the mirroring to the system. I know it seems like it's a lot. It's really probably more complex than you need it to be, and some of you that stream all the time probably have easier ways to do it, but that's the way that I'm doing it. Let me show you one more piece of this, and then we'll get right back into probability distributions. I have my calculator screen. And so here we're still looking, I transitioned the little circle at the bottom. I thought that was a little bit cooler and more out of the way. Discrete probability distributions, there's my keynote presentation, still on the screen, still able to go through and have a context for problems or whatever we're doing. And then I've got the calculator over here now. Let me talk about the calculator for a second. This is the mirror image of a TI-84 calculator. I don't think there are, second alpha math, x to the minus 1. There are some subtle differences. If you look under the mode key, where it just says X, on a regular it has X, T, theta, and N. Stat program. Most of the rest of it is the same. You've got apps. Instead of program, it says solve. So there are some subtle differences. So, but I can also bring this one up. It's a little more boring, but it's the same idea. So I'm probably going to use the newer one tonight. But what I ask you to do, if anybody shows up tonight and is watching the stream, let me know which one of these you like better, especially because we're going to get into some calculator intensive ideas here in a second. If you like this one better because it mirrors your TI-83 or 4 a little bit better, let me know. if you're okay with me using my fancy one that I've got right here that also mirrors the TI but is slightly different and may be different enough to throw you off as a student. And that's not my intent with this. My intent is to try to make some of this a little bit easier for you. So let me go back to the main screen. Hey Artemisha, thanks for stopping by. Hola. Appreciate that. Or maybe it's missing an L. Maybe it's holla. It's either hola or holla. Anyway, thanks for coming by. I appreciate it. Just going through my stream a little bit. I was trying to switch back to the main screen. There it goes. Going to talk about a few problems, walk through a few problems. This video will be up on demand for my students. I'll post it up on Moodle. It will be up in here on YouTube for anybody else that wants to come by and may use pieces of it that help you in your class. I try to go slow enough to work through the problems, and I try to work through them without mistakes. Although if you've been up here with me before, you'll know that every once in a while there are mistakes made because I work a full day, then I come home and stream. So it's easy to do. But as I've mentioned many times before, it doesn't bother me at all to make a small computational error. Human beings do that. What would bother me is if I never caught it. Typically I'll catch it. It might just take a few minutes. And then you work back because you get to the answer and it doesn't make logical sense. Okay. So I'm very excited about this new setup because I'm not overrunning. I don't even hear my fan running. I do hear it running, but it's not running like it used to on overdrive. And I'm glad I'm using the AnchorWorks camera. It seems to be working with a much better picture than it was before. It was a little washed out before. All right, so I'm going to look over this way. I've got my stuff in 2 or 3 different places, but this is throwing me off a little bit. But when you look at this distribution table, this is a discrete probability distribution. In the upper part of this, you've got the possible values of the random variable x, right? So you've got 0, 1, 2. Typically, especially in the classroom setting, those are the type of numbers you're going to see. 0, 1, 2, 3, 4, 5, or 31, 32, 33. You're just going to see some consecutive numbers there for most of the problems that we work through. Excuse me. And for each value of the random variable, it has its own probability. And then this table itself falls under some constraints, right? So, lost my place there. If you'll notice here, we have, well, one second. I forgot I had to put the pencil down on it. So right here, the summation of those probabilities has to be equal to 1. So 0.24 plus 0.46 plus 0.23 has to equal 1. In this problem, which I just made up, these numbers that I made up with no context off the top when I put this together, add up to be perfectly 1. 0.24 plus 0.46 is 0.70 plus 0.30 is 1. Yay. But if you remember, those of you students in my class, even though the summation of these probabilities has to equal 1, every once in a while you're going to have one due to rounding, whether it's before you're messing with the numbers or when you're messing with the numbers in the table itself. Every once in a while you're going to have one, like we had one in class the other night, I think it was 1.001. That's okay. It's going to be due to rounding. You need to be able to recognize that I rounded and this is what happened, or I truncated and just dropped some numbers off and this is what happened. You also may have something along the lines of 0.999867, whatever. You might have something like that. That's also 1. It's as close to 1 on this side and as close to 1 on the other side that we're okay with this. So just bear in mind that in statistics, you're not all, just because it says the summation of the probabilities equals 1, there will be quite a few instances when you're working with real numbers that it's going to be close enough to 1 that you'll accept it as a researcher, but you just have to be able to explain why it is what it is. So if somebody questions you on that, you should be able to go back and say, well, it's because I truncated that 0.24. I dropped those other numbers off and I didn't even include them. Or I included too many of them. Or I rounded up, I should say. So I have no eraser on Keynote. I don't know where eraser is. What is this? I don't know what that is. Oh. Never mind, I can highlight stuff. I'm sorry. Let me backtrack here. Okay. So one of the constraints is that the summation of the probabilities equals 1. No problem there. One of the other constraints is that each one of these probabilities in the table for each one of these values for the random variable x is going to fall between 0 and 1. It's this the range of probabilities rule that we covered when we talked about basic probability. So the probability here, that's between 0 and 1. That's between 0 and 1. And that last 0.30 is between 0 and 1. So we're good here. Our summation of the probabilities is equal to 1, and all our probabilities are between 0 and 1. I made this up with some arbitrary, not random numbers at all. Just some numbers that worked out. So, of course it's going to work. I padded my own numbers, so to speak. All right. On the other side, and one of the other things we're going to work with tonight, and I'm going to use the calculator to work through these again, is that if you want to find the mean, and I didn't annotate it. I can do it right here. I actually love Keynote. I think it's much better than PowerPoint and some of the other programs that you might use. But it takes a little bit of work to finagle. So right here, this is the mean. Oh, that's terrible. Let's go yellow. This is the mean, and this is the variance. Now, and I'm just kind of reviewing a few things before we go into a problem. But remember, the standard deviation and variance have the same relationship here in these discrete probability distributions as they did when we worked with them before. In other words, that mathematical relationship is just as follows. If you are looking to find, if you're looking to find the standard deviation, it's just going to be the square root of the variance, which is all that other junk here. Okay, so that's what we're going to be working with here in just a few minutes. Got a few I don't have but a few problems. So if anybody has any input or any questions or anything, throw them out there. I will say this for anybody from my class that comes back and watches this video on demand. We do have a vocabulary quiz this Wednesday, so don't forget tomorrow night we've got vocabulary, so study up. I posted that on the Moodle before class last week, the note set, and then I gave it out in class. Nothing major to it, just be able to regurgitate it. Again, that's my way of forcing students, in order to get a good grade, to connect with the vocabulary and the symbolism. Maybe it's an archaic way, but I find it gets a little bit of results. I did the last test, or the first test we had, the average was 71, which is about 7 points higher than the average usually is on that test. So, just saying. All right. So let's move on into what? Timeout. Okay, sorry. Here we go. I forgot I got to use this. Okay, let's construct a discrete probability distribution. So we're looking at the number of dogs per household in a small town. It goes kind of like I think I did a TV example in class, very similar to that. In other words, in this small town, if I randomly select a household, what is the probability that that household will have 0 dogs? Or what is the probability that that household will have 1 dog, 2 dogs, 3 dogs, 4? That's what we're looking for. We want to build the probability distribution. Well, it's going to look like this. We're going to have dogs. We're going to have the probability of the number of dogs right down here. Now, if I randomly select a house, I could have 0 dogs. 1, 2, 3, 4, and 5. So that top part stays the same. The bottom part doesn't. If you notice up in this upper right-hand corner, I've got the rules that we walked through in class kind of formalized. So you can write these down if you're a student in my classroom, or you can just take note. So if you let x be that random variable with the possible outcomes, x sub 1, x2, x3, x4, whatever the outcomes are, in this case we've got 6. You make a frequency distribution for these possible outcomes. That's what we've got up here. That's a frequency distribution. In other words, when they did a study before, whether it was from a survey or whether they actually invaded homes and counted the dogs, whatever they did, in this town, when they did this study, they found that 1,491 homes had 0 dogs. 425 dogs had 1 dog. 425 homes had 1 dog, 168 homes had 2 dogs, and 48 homes had 3 dogs, and so on and so forth. So that's how many dogs they had when they did the experiment originally. So we need to take this, we need to find the sum of the frequencies. In other words, I really do wish I had an eraser here. No, it's not that. I apologize. So what I want to do is I want to, apologize for the delay anyway. I want to add these up. So I'm going to go right here and I'm going to take 1,491 plus 425 plus 168 plus 48 plus 29 plus 14, and I get 2175. And before I go with that number, let me double check. I had 1491, 425, 168, 48, 29, and 14. Notice that I'm using my TI, whereas before, and I was very excited way back when I was able to use the document camera to push it out to my stream. I ran into some problems with that document camera though, because it would get fuzzy. I'd have to reboot it, then it wouldn't read it. I'd have to shift it all the time. I was always running into it. Now that I've got these other ways that I can use a calculator, which we'll get to in just a second on my iPad, I feel a whole lot better. So, okay. I'll keep this green for down here. When we're finding the sum of the frequencies, I just found that it's 2175. So if you go right up here, 2175 was the sum of my frequencies. Now find the probability of each possible outcome by dividing its frequency by the sum of the frequencies. So the probability of me getting a dog is getting 0 dogs when I randomly select a home is 1,491 over 2475. 1491 divided by 2175. So there's a pretty high probability, which makes sense because we had that instance of almost 1,500 homes with 0 dogs quite often. 0 dogs was just quite often what we came across. So I'm going to, and here we go into a situation, don't know if you can see that, but it's 0.6855. So I'm going to put 0.6855. Okay? I'll round out to 4 decimal places to try to keep some semblance of accuracy here. And again, we're finding the probability of each possible outcome by dividing its frequency by the sum of the frequencies. So for I didn't mean to do that. Back to green. I think I accidentally hit it. So we've got 425 divided by 2175. 425 divided by 2175 equals 0.1954. All right, no problem. For 2, it's 168 divided by 2175. For 3, it's 48 divided by 2175. For 4, it's 29 divided by 4175. And for 5, it's 14 divided by 2175. So I'm just going to walk through these real quick. 168 divided by 2175. 0.0772. 48 divided by 2175 equals 0.220. Hopefully it's fairly legible, yeah. 29 divided by 41. No. Actually, it looks like 41. I apologize for that. It should be 21. See how it's easy just to make a mistake. Human error, let's get 0.133. And the last one, 14 divided by 2175 equals 0.0064. So notice in my denominator for the fourth instance right here, I've got 4175 accidentally. I almost typed that in without thinking. I was just reading it and typing it in. Where would I have found my mistake? Well, if I'm a good student and I'm working with discrete probability distributions, I'm going to make sure that the sum of my probabilities is equal to 1, right? So I'm going to do that right now. It would have not been close to 1 if I'd have used that denominator. In fact, it would have been 29 divided by 4175. I would have had 0.006. So I'd have been off by about 0.006. So by about 0.007. So it wouldn't have been off that vast, I guess, but still would have been off. So let's go 0.6855 plus 0.1954 plus 0.0772 plus 0.0220 plus 0.0133 plus 0.0064. And I get, yay, I'm glad I got this. For my sum here, I get 0.9998. And I took it out to 4 decimal places each time. That's 1. So my sum of those probabilities equals 1. And do each of those probabilities fall between 0 and 1? So in other words, oops. Do each of those probabilities fall between 0 and 1? The answer is yes. They're all decimal numbers. There's no leading whole number in front of them. So there we go. Okay. No questions so far. That's fine. I was really astounded last week, I'll be honest with you. Like tonight, there's a couple of folks at least lurking in the background. And I see Artemisia showed up, and I appreciate that. Appreciate anybody that stops by. Last week, I had like 187 views on my online office hours. Last Thursday. So apparently last Thursday was a very slow night around the world. And people were just like, they couldn't find anything else. Okay. Hope this helps. I'm now going to move on to another problem. Actually, I'm not going to move on to another problem. I'm going to utilize this one. And I'm going to switch to my calculator view. Look at that. Great. I love it. And I'm going to use this fancy dancy calculator that I have purchased for little or nothing on the iPad. Excuse me. And what I'm going to do here is I am going to... Let's see what I am going to do here. I've run out of room. That's why I'm sitting here staring at it. So I'm going to... Daggone. What I was trying to do was work with... Let me do this. I'm going to work with these. So maybe I'll outline what I'm going to do here on the calculator. Then I'll go back to the numbers. So basically, in order to find the mean, in fact, I'll work with this one. And then I'll go back to the other one and find the mean, the variance, and the standard deviation. So in order to find the mean of this particular example, this previous easy one that I arbitrarily made up that is so easy, caveman can do it. You just put everything down. Everything works out. Sum is 1. We're going to work with this one. And I'm looking first at the mean. So if you look at that, mu equals summation of x times the probability of x. Well, I'm going to have to put these in the calculator. So just 1 second. Okay. So if you go to stat and you hit enter, now you're in edit. I need to enter these. So I've got 0, enter, 1, enter, 2, enter. That's it. And so this should be delete and delete. So 0, 1, 2. Scroll over into L2, and that is hard to see, isn't it? Well, 0, 1, 2. That seems to be a little bit easier to see. And then I've got 0.24, enter, 0.46, enter, and 0.30, enter. Okay. So In L1 are my possible values of the random variable x. In L2 are my probabilities of each value. So the probability of 0 is 0.24, yada, yada, yada. Okay, so I've got everything in there that I need. Well, I need to do this. I need to find the mean. And I want to do it using the calculator. So I'm going to scroll over here and scroll up to L3. This is a very small set, so I could work it out on paper. It wouldn't take long. Or I could just work it out with the calculator. Punching in numbers wouldn't take long. But we're going to walk through this smaller example using the tables in stat. And so we're going to, we need to take the values of x, which are in L1, and multiply them by the values of the probabilities, which are in L2. So the bottom line is this becomes L1 times L2. That's what this formula becomes. So what I'm going to do in L3, and you have to scroll up to L3 and be actually on the L3 or whatever the title is up there. I'm going to go second L1 times second L2. And if you notice right there, in L3, what it's going to do is populate that all the way down. There it is. And the first one, 0 times 0.24 is 0. 1 times 0.46 is 0.46. And 2 times 0.3 is 0.6. No problem. I need to find the sum of that. Again, a very simple example. But if I've got many more of these, I want you to know how to do it. So I go second. No. I have to say second quit. I have to get out of there. Then I go second stat. Then I'm going to go to sum. There it is. Sum. And I'm going to go to second L3. Close that parenthesis. And I get 1.06. So my mean for this problem was just taking the value of x times the probability, value of x times the probability, all the way down and adding it up. That gave me the mean. And it's 1.06. So let's put this into perspective. 1.06 is somewhere right here. Just barely past the 1. Does that make sense? Yes. Because 46 is in the middle. And that 30 is a little bit bigger than 2.4, but not much. So it's going to pull that distribution that way. So that mean is 1.06, no problem. Gosh. That's the only problem in using Keynote and writing over the top of Keynote. It's absolutely fantastic, but I don't have all the things that I have with those areas. So I got to figure that piece of it out. Okay, so we've got the mean, no problem. Now let's find, I wish this did something. Now let's find the variance, which is going to be summation of x subtract the mean, which we already know to be 1.06 squared times probability of x. I'm going to put this formula in there. So I go back to stat, I go to edit. I've already got the mean, so I can scroll up to L3, hit clear and enter. Whoops. Actually, this calculator is a little bit different. Okay. So I actually had to hit the delete key for each individual one. So I scroll up to L3, and I'm going to put this formula right here in terms of the calculator. So in terms of the calculator, the x is L1. The mean stays 1.06, no problem. I square that times L2. It's the same idea. I'm just changing the formula that we're using with the statistics into the syntax for the calculator. So I've got parentheses, second L1, subtract 1.06 squared times second L2. There's my formula. And that's exactly how the formula first in statistics, any class you walk in the world for a discrete distribution, it's the same. We just transfer it to the syntax. I hit enter, fills in down below, but I have to get the sum of that. Remember, that's part of the formula too, so I have to go second quit, second stat, sum of L3. 0.5364. So the variance, what did I use, green? The variance is 0.5364. Okay? So I found the mean and the variance of that particular very simple problem. All right. So let's go back to our problem from before. Let's see if I can... There it is. We got the same thing here. And I'm going to go back to my other calc. I'm going to try to use it. We've got a different situation here. I'm going to put the numbers in the calculator here, and I'm going to do the same thing. I'll find the mean of this distribution and the variance. Notice I didn't find the standard deviation for the last one, mainly because I ran out of room in that mess of a screen that I had. But all you would have to do is take the square root. So in this particular one, 0, 1, 2, 3, 4, 5. So 0, 1, 2, and we'll go 3, 3, enter, 4, enter, 5, do. This is 4, enter, 5, enter. Okay, now scroll over here. I'm going to put the probabilities in, which we came up with just a few minutes ago. So it's 0.6855, enter. 0.1954, enter. 0.0772, enter. 0.0220, enter. 0.0133, enter. I might check this in just a second to make sure I didn't not type it in right. So 0.0064, there we go. So 0.0064, 0.0133, 0.0220, 0.0772, 0.1954, and 0.6855. Okay, no problem. Now I'm going to go to L3 and I'm going to put in the I use black at the top up here. I'm going to put in the formula for mean, which is just simply the summation of the x values times the probability of x values, which, if you remember, we're gonna transfer this to the syntax of the calculator, which instead of x, I'm going to have L1 times L2. No rocket science about that. Now, I apologize that I'm writing over the top of this. I really do have to find I may have to pull my keynotes into Doceri so I can bring Doceri, share that. I don't know, I'm just talking to myself. So let me put the formula up here. Scroll all the way to L3. You have to be in L3. If you do it anywhere else, it's going to try to put it just in that one. It's going to give you an error. I was going to try to put it in the cell. So right here, I'm going to go second 1, which is second L1, times second 2, which is L2. There's the formula. Yes, they'll be just like this. No difference at all. Yep, problem sets. Enter, and it scrolls down. So there's all the numbers that you need to add up. In other words, 0 times the first one, plus 1 times the second one, plus 2 times the third one, and so on and so forth. Artemis, they'll be certainly different numbers, but they'll look just about identical to this. I need to find the sum of this now, so I'm going to go to second stat, actually second quit. I got to get out of there. If I don't, it's going to try to insert it into the spreadsheet. Now I go to second stat, scroll over to math, scroll down to sum. Sum, there it is. It even gives me the syntax down there, but I just need to find the sum of L3. Enter. And it's 0.501. So the mean of this, 0.501. That's the mean. Make sure I read that right. As you see me looking around, I'm looking on my program that I'm streaming with, Ecamm. Then I'm also looking on my screen where the calculator and everything is, and just making sure that everything's showing up okay. That's a hard to see screen on the calculator, I will admit that. The other calculator is a little bit better in that respect because it's darker. and everything's a little bit taller. So 0.501 is the mean of this probability distribution. And so I'll go to white here to stand out in this. 0.501. Oh. It's a half, it's way down here. So the mean, if you remember when we talked about skewed one way or the other, the mean always pulls things out if it's got an extreme value. If it's got extreme values at either end. In this particular problem, at the 0th point, 1491 is vastly extreme compared to the other one. So it's going to pull that mean back that way. So this mean of 0.501 makes sense to me in the context of this problem. So I feel like I did the work right. Now I want to find the variance of this. And man, I do apologize that this is looking like it is. I'll experiment after this. Won't do too much now. I'll finish this up. I'll start another problem. Then I'll probably close for the night on these particular problems. But anyway, you see what I'm doing. I'm troubleshooting right now to try to make the stream better. All right. So if I want to go back to Stat, Edit. I'm going to scroll over to L3, and I'm going to go up here, Clear, Enter. Clears it out like it should. And now I'm going to scroll back up to L3, and I'm going to put the formula for the variance. And the formula for the variance is, I'm trying to figure out what color to use. I'll use black on this side. Summation of x, subtract each x value, subtract the mean, which was 0.501, square it, and then multiply it times the probabilities. Okay. All right, one second. My wife is self-cleaning the oven, and it's kind of stinking. Let's fill in the room. All right, so there's what we're going to use. So let's go up here, and I'm going to put this in terms of the calculator. And in terms of the calculator, it's going to look like this. It's going to look like L1 subtract 0.501 squared times L2. Okay? So I'm going to put second L1 subtract point. Now, all of a sudden, I've lost my feed on the calculator. 1 second. Still showing on all my stuff. Okay, now we're back. Not sure what that was. We'll put the formula in. I've got L1 subtract 0.501. Close, square, no problem, and then multiply times second L2. You hit enter, fills in all the way down. Beautiful thing. I wish I could zoom in on that. I'll figure that out too. So then I hit second quit, because what I need to do now is second stat, scroll over to math, scroll down to sum, and I'll take the sum of L3 equals. Did I put it in L3? I did. Okay. So it's 0.8239. Okay. There's that. There's that. So I've got the mean. Let's use this. I got the mean right there. I got the variance right there. If I want to find the standard deviation, I would just take the square root of 0.82 8239. Yep, that would be it. Okay. Whew. That seemed like a lot, didn't it? I walked through a lot of things here. Let me check something. All right. Okay. So I think what I will do right there is I think I'll close for the night. I think I'm going to actually mess around just for a minute. So if you come into the stream and it looks like I'm dinking around with stuff, I'm messing around with the stream just for a second to see if I can figure out how to get my keynote into my Doceri so I can transmit that and have more tools when I'm writing so I can erase out. So Artemisia, thanks for stopping by. Anybody from class or anybody from the world that stops by and sees my live, I appreciate it. Leave a like. I'm going to keep putting videos up here as long as I can. Do the lives. I do them twice a week for my class, and I'm always looking to improve these. So if you got some suggestions, leave them in the comments. If you've got some things, ideas for the stream, leave them in there. Yeah, that's about it. I'm putting up calculator videos as fast as I can. I do wear out during the week. Don't always get them up like I would like to. And that's where I'm at. So right now I'm going to put it on the pause screen and I'm going to mess around, with the iPad. I'll be back in a second, but for all practical purposes, I am done. And I appreciate everybody that stops by and watches this video on demand. Thank you. So I think what I'm going to have to do, I'm just kind of talking out loud, this is kind of just practice page, I was just thinking around. I'm going to have to bring freeform up or something to that effect. Or doceri. At least I can work with the tools. So again, if you just popped on, I am just trying. I've actually done with the stream, but I wanted to go through a few setups for what I've got here. So what I'm going to do is all right, back to the drawing board. So let me go back. Oh my gosh. What I do with 360. I wonder. Okay. Well, I think what I'm going to do is sign off. I got a whole lot of chaos up here. Again, I appreciate anybody that stopped by, and I'm going to sign off and mess with this, try to make it better for next time. Thought it went pretty well tonight. Thanks.